Hello everyone. Welcome to another day of LeetCode Live. I want to start off today's stream by explaining a little bit of how things will change, and I probably should, and I think I will make a video detailing a little bit about this. It's nothing crazy and it's nothing negative, so don't be nervous. Everything's going well in my life. I just want to talk a little bit about how things are going to be changing from here on out. So if you've been following me since the beginning of my entire journey of doing every single LeetCode question and going on this streaming journey, you know that I started on July 16th, and I've been, I would say, very consistent since that day. However, in the past couple of days, some things have changed. One is the fact that in 3 days, I'm going to be going on vacation, and I was hoping to have some pre-recorded videos that I can share with you all right when I start going on vacation. That way there's no loss of content, but I think because of something else I'm about to talk about, that may not be as likely. There is going to be some content, however, it might change. And really the thing is, today I started going back to the physical location in my office. So since the start of the pandemic on January 2020, I was working remotely, and just today I started going back to the office. So what that means is, for example, when I was working from home, I was a little bit more flexible in my time. I was able to maybe do the stream a little bit earlier, so I don't have to really worry too much. But now I go to the office physically. I also go to the gym in the office, which means I come home a little bit later than usual. It also means that, I want some time to spend with my girlfriend. Depending on the day, I can be a little bit tired. So there may be some times where I might not be able to get to a stream because, well, frankly, I just value my health. And, obviously, I really do enjoy the LeetCode live streams, and it's been a lot of fun since the beginning. But I also need to make sure that I, of course, have time to spend with my loved ones, and I also don't burn myself out. So with that being said, that's why I'm coming today a little bit later than usual, and I suspect it's probably going to be the same thing from here on out. Now, one of the good things is the going back to work thing is not mandatory in the sense that I don't have to go 5 days a week. I can sort of be a little bit flexible, which means mostly I'll be going 2 to 3 days a week starting now. That's how it's going to be. So if you see me start streaming a little bit earlier than normal, it's probably because I'm home. If you see me streaming a little bit later than normal, like today, it's because I worked in the office. So I just wanted to make that known. I'll make a video about that to let other people know in case they don't watch the stream, but I hope, I don't want this to deter anyone. I'm always going to be putting content out, and I'm going to do my best to let you know if there's going to be a slowdown of content. So with all that being said, I appreciate all the support that everyone's given me. It's been an absolute blast to go through this whole thing. I've learned so much from not only the viewers, but also myself just going through all these different questions. And with all that being said, I know it's a little bit of a longer intro, but I think it's important for me to be transparent with everyone. So let's go ahead and get started. Today we're going to do some easy questions, and we are going to start on page 4. We're sitting at 306 questions. Very happy about the progress that we've made here. And I'm going to go a little bit further down the list because I know that we were sort of hovering around some questions that were weird. But let's go and let's see, distance between bus stops. I think this is a good one for us to start in. All right, so 589 and 60. So we have a nice like to dislike ratio. So all that is good. Let's see what we get here. So a bus has n stops numbered from 0 to n-1 that form a circle. We know the distance between all pairs of neighboring stops where distance I is the distance between the stops number I and I plus 1 modulo n. The bus goes along both directions, in other words, clockwise and counterclockwise. Return the shortest distance between the given start and destination stops. So we have this array that represents distance 1, 2, 3, 4. We start at 0 and the destination is 1. The distance between 0 and 1 is 1 or 9. Interesting. So let me see this again. We know the distance between all pairs of neighboring stops where distance I is the distance between the stops number I and I plus 1 modulo n. The bus goes along both directions. All right, the distance start is 0 and 2. Distance between 0 and 2 is 3 or 7. And is that because, let's see, so what's the formula? Distance between the stops number I and I plus 1 modulo n. Distance I, so this is going from I plus 1 to 2 plus 3 modulo n. Okay. So is that because it's just like 4 and 3? That's 7. Wait, 4, 3. Okay, that's 2. Okay. And then from 0 to 1, that's 1 plus 2. That's 3 or 7. So here it's what? 1 plus 2 is 3. 4 plus 3. Oh, they're going from start to 3. So we can go 1, 2, that's 3, plus another 3, that's 6, or just 4. So the lowest one is 4. Okay, so I kind of see what they want here. So let me see if we can draw this out and think about this a little bit better. By the way, the stream today, again, only because it's later in the day and I do have to like have dinner. It might be a little shorter than normal, but that's fine. We're having fun here. So distance is, whoa, okay, 1, 2, 3, 4. And if we start at 0 and we're going to 1, okay, so from 0 to 1 is 1. From 1 to 2, okay, I see. And then finally, or we can go the other way around. So we can go from 0 to 3 is 4. And then from, okay, so we just continue adding it until we get to, let's see, destination 1. So how would we be able to get there? So if we're going to 1, we just add 0 to 0 plus 1. This is 1 to 2. Okay, so it seems like we could add, like how would it go in one direction? I'm just trying to figure out how it would go in one direction here. So we could just go all the way from some number to the other. If we were going from like 3 to 1, right? This is just being able to traverse this in, it's almost like a circular queue, right? So I guess both ways that we would go, if I was going 0, 1, 2, 3, if I went 4, like it'd be nice if we just had a, how do I say this? Yeah, we really just need to go in a circle, counterclockwise and clockwise, and we could accomplish that with modulo operations. So if we have a 0, right, if I do 0 modulo length, right, if it's 1 modulo 4, that's still that. If it's 2, that's still that. If it's 3, that's still that. And once I get to 4, which would be out of bounds, right, if I tried to go to index 4, which would be out here, that would turn to a 0, that would just be this. And that would still be the one that I want to go to anyway. And then again, if it became 1, oh, I just got a message here on Discord. Nice. So that's that way. And then if we went the other way, it'd be the same thing. So 2, 1, 0. And then, well, what happens if we get, well, I guess if we get to 0, if we get to -1, we can just reset it to 3. That's like one way that we can do it. So imagine that we want to figure out, let's say I want to go start 3 and destination 1. There's 2 ways that we can do this, right? If I'm at 3, let me see, 0, 1, 2. So 2 to 3 is 3. So let's say if I want to go from index 3 to 0, and let's say current distance, let's see, this would be, I'm going from 3 to 0, so 0, 1, 2. Actually, let's go from 2 to 0. We do 2 plus 3, 2 to 3, that way, which would be 3, which is this 3 here. Then we go from 3 to 4, so we'd add this 4 here. That would be 7. And now we go out of bounds. We'd go out of bounds there. So then we should go from, like, let's say that would be index, like 4, for example. So then we would just add the 1, right? So that would be 8. So if I go from index 2, 2 plus 3, or rather 0 plus 3 is 3, 3 plus 4 is 7, 7 plus 1 is 8. Okay, cool. And then if I want to go the other way, I could just subtract. So I can go from index 2 to 1, and that would be node, let me see, 0, 1, 2 to 1. Oh, but see, that changes things a little bit. Because if I go 0, like 2 to 3 is 3, 2 to 1, distance between 0 and 1 is 1 or 9. Is there like, there might be an even easier way of doing this. 0 to n minus 1, distance I is the distance between the stops number, 0 to 1 is 1. So if I want to 0, but it doesn't work the other way. 0 to 1, 1 to 2, 3. This is 3 to 4, but if I go from 3 to 2, if I go the other way, what would that distance be? 2 to 3 is 3. I guess 2 to 1. Oh, I see. So the index there, 2 can represent both things, right? Like index equals 1 can be the distance from 1 to 2, or it can be the distance from 2 to 1. Yeah, that's fine. Okay. So now I need to figure out how to like put all this in code now. If they give me a start and a destination, 0 and 1. They give me a start is 0, destination is 2. Here they give me a start of 0, destination is 3. Do we always start at 0? Shortest distance between the given start and destination stops. 1, 3. That's 1, 2, 3, 6. Or 4, 0 to 1. Trying to think about why this one's 4. Yeah, these like circular queue questions always like trip me up. It's always like trying to figure out that index and how I can like go around. Even though I literally just did the math with like the modulo there. I guess I can just continue going right until I get to my destination. That could be a way of solving it. Like we could have, let's start index equals start. We can say while start index not equal to destination. I can say let write distance equals 0. Well, start index is not equal to destination. I can use that modulo trick when I'm going right. So I think that's probably fine. So write distance equals, or plus or equals, distance of start index plus plus. Let's see now. The start index, I guess start index should be start index plus 1 modulo distance dot length. And I should probably have start index start. That's start modulo distance dot length. So start index here is 0. 0 modulo 4 is still 0. So 0 is not equal to 3. So we'll start at 0, we'll add 1. Then we'll go to the next one, we'll add 2. That's 3. We'll add another one. Let's see, start index is not equal to destination. Maybe we have to set it that while start index is less than destination, because I still want to do it, or I guess it can be less than or equal to destination. Because what is it that I'm trying to do here? I'm all over the place right now. Start index will equal 0. And then we have the write distance here. So is 0 less than or equal to 3? Yes, it is. So write distance is distance at start index, which is 1 in this case. And then we increase this. Now start index is 1. Is that less than or equal to 3? Yeah, it is. So we add this one, which is 2. So this becomes 3. We add another one. Is it less than or equal to destination? Yes, it is. So we add whatever's there, and that's 6. And now we increase this. But now it's no longer less, so we stop. And now the right distance is 6. Now for us to go the other way, we only want to add, I guess what I could also do, start index. Maybe I can reset start index here. Or I don't even actually need to, right? Oh yeah, because I'm modifying it. So maybe I can just do this, start index equals start modulo distance dot length. And now for us to go the other way, 6 or 4. So I need to first subtract and then get the thing that's there. And I guess we can do the same thing. Here I can say while start index let's see, do I want to do it that it's not, I don't want to do it while it's not equal to the destination, because like I also need, I need the destination, right? Or do we just take, or maybe we don't. Maybe on that side we don't. Well, let's figure it out. Well, start index is not equal to destination. What I can do here is I can subtract 1 from it. Start index minus equal 1. If start index is less than 0, start index equals distance dot length minus 1. And then here we can say, now we add the left distance. So let's say let left distance over here. Let left distance equal 0. Here I can say left distance plus or equals. This should also be start index equals start index plus 1. Left distance plus or equals distance at start index. Okay, so let's see how this whole thing kind of pans out. We have this being 0 again, and let's use this as an example. So start is 0, destination is 3. Okay, so start index starts at 0, that's less than or equal to 3. So to my right distance, I can add whatever is at start index 0, so that's 1. Now I'm going to say start index equals start index plus 1, so that's 1 modulo 4, that stays as 1, so we increase this. 2 is still less than or equal to 3, so to right distance, I can plus or equals distance at the start index, which is just this 2 here, so now this becomes 3. We increase start index. 3 is less than or equal to 3, so we add whatever's currently at this index, which is 6. Now we increase 1. Now start index is less than or equal to destination, so we stop this while loop. Now we reset, or rather now we say start index is equal to, again, 0. And now left distance equals 4. While start index is not equal to destination, so 0 is not equal to 3, we can subtract 1 from start index. And now because it's -1, we're going to reset it to be here. So it kind of wraps around, right? And now we say left distance plus or equals distance of start index. So this will be 4. And now we just return the minimum of 6 or 4. Now I want to try for another one here. Let's try start equals 0, destination equals 2. So 0, 2. So this one kind of uses a little more. Or 0, 1 might be better. I feel like this actually uses more. So again, let's reset these both to 0. So here we start at 0. All right, so is 0 less than or equal to 1? It is. So we add 1 to right distance and we increase. Is 1 less than or equal to 1? Yes, it is. So we add what's currently in. You see, so I don't think we need to. That is destination 1. That means we've already gotten there. So maybe this should be the same too. While start index is not equal to destination. So we add 1. Start index is now 1, so we've already arrived. So it took us 1 to get there. Okay, now the other way. So is 0 equal to 1? It's not, so we subtract, and that means that we wrap around, and now we add 4. So that's 4 here. We go down 1, we add 3, so that's 7. Go down 1. You see, but this is the tricky part. Why wouldn't I add, like, in my head, I'm already distance between 0 and 1. Oh, because I'm not also adding. Does it only matter the other way around? Maybe for the right distance it doesn't matter, but only if I'm going left, I also need to add this one. What if I if I set this one to true? That seems weird though. Like, I'm almost thinking like, you set this to true. I can keep doing this. Start index minus equals 1, so I'll get here. I'll add it. And then here, I can say if start index is equal to destination, we just break. Because we will reach our destination at some point. So let me go back to, I guess now let's use this one. We've been going over all these manually, but it's good to do that. Start index is 0, destination is 2. All right, 0 not equal to 2, so we add 1, increase this. 1 not equal to 2, so we add 2, increase this. 2 is equal to 2, so we don't do anything. Okay, so we do have the 3 now, so that part's correct. Now let's start on our left distance and see what we get. Starting at 0. All right, start index minus equal 1, so now we wrap around. Left distance equals the 4. We go back 1. It's not equal to, it's not equal to 2, so we don't do anything. We add the 3 here, so it's a 7. All right, now we subtract 1, so we're here. It's not less than 0. So maybe I should actually move this up here, right? Because I want to first to see, I first want to check to see if we're at the destination before I try to add anything to left distance. So I think this could work. It seems a little bit odd though. I feel like I think I made this more difficult than it needed to be. I just haven't found the pattern exactly. And then here we can return the minimum of right distance or left distance. This is my first shot at the question. So let's see what we got here. Okay, 1, 3, and 0. Okay, so that last one is incorrect. We did good on the first two. It's this last one that's wrong. So all this looks fine so far. Let's again do the same thing that we always do. Write down our input array here. We have our start. Start's not equal to destination because we're going to 3, so we add 1. We increase, not equal to 3, so we add 2. We increase, not equal to 3, so we increase. Now this is equal to 3, so we don't do anything. So 6 is right for the right one. Now let's see what happens when we go left. So we should have gotten a 4. So let's see. Start index minus equals 1. It's less than 0, so we go here. So this is the weird part, because should I add, like, why wouldn't I? Because my thing here is like, if I'm already at the destination, I don't want to add anything more. But maybe I need to at least, I think it works differently the other way around. Let me see how I had it originally. Let's run this again now with that one change and see what we get. 134 and 134 for all test cases. So let's give it a shot. We're going to submit it and see what happens. All right, cool. 58.11. Yeah, this one, again, I think I probably made this one a little more difficult than it needed to be. There definitely is, I'm assuming there's some formula or something that we could use that would make something like this go by much faster. I want to submit it again and see if that time changes. 90.54. Pretty happy about this. I mean, at any given point, I guess we're not really going, the time complexity here is a little bit weird because, like, in the worst case, we can be going from like 0 to 3. Like, I'm going to be hitting all the elements at least once. I'm going to be going through this entire array at least once. So I would say that the time complexity is linear. And I would say that the space complexity is constant for this one. But let's look at discussions and see what it has to say. C++1 pass. So if start is greater than destination, swap start and destination. Well, what does this mean though? Make sure start comes before end. Calculate the sum of target interval as well as the total sum. The result will be the mean target interval sum and the remaining interval sum. If start is greater than destination, you swap them, okay. For int I less than distance dot length. If I is greater than start and I is less than destination. But see, like, why does this make sense? The thing is, I want to understand why. right, I did something like this. If the start is greater than the destination, swap them. Use the prefix sum to compute the distance between given two stops. Okay, because you're using a prefix sum here. I mean, wouldn't R still be like maybe not as elegant, but still the same thing with a linear time complexity and constant space complexity? Not using any extra storage here, so I think that's fine. I'm okay with that. So I'm gonna go ahead and continue here. Let's get to cousins in a binary tree. This is chat. All right, nice like to dislike ratio. Given the root of a binary tree with unique values and the values of two different nodes of the tree x and y, return true if the nodes corresponding to the values x and y in the tree are cousins, or false otherwise. Two nodes of a binary tree are cousins if they have the same depth with different parents. Okay, that's tough. Same depth, but different parents. So x5, y equals 4. Yep. 4 and 3. No, because they're at different depths. One thing I'm thinking is doing like a level order traversal. I think that's something that we can get. X equals 2, y equals 3, that's also false. Each node has a unique value. If I were to do this using a level order traversal, how can that help me? Each node has a unique value. Or we can do something where like we always pass the parent into this node, but then it's also hard to like keep track of the depth. Whereas with the level order traversal, I will at least know that if I see both of them. Now, can I check its parent? What's an easy way for me to get access to the parent? Is cousins. What if instead of necessarily checking for the parent, I can check each, like whenever I push something, because level order traversal, it's like I'm gonna push the 2 and I'll see if it has any children, and I'll also push them. So like at some point I'll have both of these, and I can also say what their parents are. So at some point when I have both of them, I can just return whether or not they have different parents and they're at the same depth. I mean, that's one way of doing it. I also know with the normal algorithm I use when I'm operating on these arrays, well, am I always going to be in the same depth? Yeah, I think maybe I'm going to go with something like that, or I'm going to use like, I'm going to do a level order traversal, and for each node I'm actually going to like push an object, and maybe that object will contain the level that we're currently on and also like the value of the parent, because it says everything here is unique. So maybe I just need the value, and then whenever I find x and y, I can check to make sure that they're on the same depth, and also they have different parents. So let me see. How can we do this? Kind of want to do something like let xref equals null and let yref, these are just references to these. I'm going to set these equal to null. Then I'm going to set this up like I normally would. I'll just make this a let to keep things consistent. I'll have root and null. And here I'll say while true here. So let's get the first one. Let node equals q dot shift. Here we'll do something for if node equals null, else. This is where we actually push new things to our queue. Now what I should do here is I should start setting this up how I want it, right? So let's see, node here can be root and depth can be 1. So I'll do something like this, where it's an object with node root and depth 1. Else, what I can say here is I can say if node dot left, then I can say q dot push, something similar, where I say node is equal to node dot left depth. Wow, node dot left. Wow, node dot left and depth is actually 2, right? Because that's going to be one of the children. So that will necessarily have a depth of 2. But wait, I also shouldn't make, I shouldn't make this, what, if anything, what I should do, if node dot left, if node is equal to null, it should be whatever the depth of this one is, right? So it should be node dot depth plus 1. This one can also be node dot depth plus 1. And let's also see if node dot left, if node dot right. So I push both of them. Let me think about this. I guess what we can also do is if it's not null and the node that I just pushed off, so if node, and it seems a little bit not really my favorite thing right here, but if node dot node dot val is equal to x, because x is what, a number? If it's equal to x, I can say xref is equal to node dot node. If node dot val is equal to y, we can say yref is equal to node dot node. And finally, what we could technically do here is I can say if xref not equal to null and yref not equal to null, then here we should return xref. Let's see, xref is node dot node. Okay, well, we shouldn't just get the node. I should just do this, right? Return xref dot, let's see, depth is equal to yref dot depth. Oh, but wait, I completely missed the part where, but see, I also have to even add the parent. I'm not really in love with that. Node dot left. Because for all of these, yeah, probably overcomplicating this. Like pushing the information every single time. I kind of just want to like save copies of all these. Every single time I push into my queue, I push information of the parent. Well, I guess I can actually, yeah, maybe that wouldn't be as bad. Here I can say, yeah, let's do this instead. Here we can say parent is null. The depth is 1, I suppose. Or this really should be 0, right, for that first one. When I push it the next time, if node.left, q.push. Let's see, and which one would this be? Would it still be node depth plus 1? Yeah, too much information here. I think I'm overcomplicating this like a lot. I feel like I'm having to make this huge queue with all this information about each one. Like I'm just carrying around a lot of information where there can be a more simple way of doing this. It's just like a code smell that you develop. I want to look at another one. Like it's crazy how much, kind of like on an off topic, but it's really crazy how much just being in the office like drains you of energy. I normally don't do my streams this late, but I'm like really low on energy. Given two strings s and goal, return true if and only if s can become goal after some number of shifts on s. A shift on s consists of moving the leftmost character of s to the rightmost position. A, B, C, D, E, B, C, D, E, A after one shift. Well, I think like there's definitely a trick here, right? Because you can do an infinite amount of shifts as long as the letters are always like in the same order. Like A, B, C, but E comes here, and that's where it gets messed up. A, B, C, D, E. Here we can still do A, B, C, D, E. So what is it that I would want to see here? What is it that I would want to do? I could, like, what if I save the no, I don't want to save the indices because C is less than D here. Well, C is always less than D, but A is not, yeah. I can keep rotating goal over and over and eventually just land back at the same character. Also, what is, okay, this consists of lowercase English letters. A, B, C, D, E, A, B, C, E, D, because the E is coming after the C when it should be D. What if I create a map of like the letter that always comes after each one? So like C, like D should always come after C. Is that the case? A should always come after E. C always after B. Because then I could look at D. Or maybe I should just say what comes before. Before B comes A, before C comes B, before D comes C, before E comes D. ED, before B comes A, before C comes B. We could do that. What comes before B? Okay, but see, what comes before A? Before C, B, what comes before D, C? Do I only need to check those? No, I feel like I need to check what comes before E is A, but what comes before A? It should be E. What comes before B, C, D, what comes before E? I think I could maybe do something like that. Like I'm thinking of having like const previous map is this. So we can do for let I equals 0, I less than s dot length, I plus plus. Here I can say if I is equal to 0, and we can say previous map of s of I equals previous map of s dot length minus 1. And then else we'll just say it's the previous one, right? So previous map of s of I is equal to previous map of s of I minus 1. So if I console log this, could this work? I just want to see the answer, or not the answer, but okay. A undefined, all this undefined stuff. Awesome. And why is that? What is S here? I equals 0, I less than S dot length, I plus plus. If I equals 0, the previous map of S of I, which is A, equals previous map of S dot length minus 1 E. This is one of those that is like, I think to myself, why is it getting undefined here? A, B, C, D, E. Is this not right to use like S here? I equals 0, previous map. What doesn't like? It's just like completely wrong. Okay, A, B, C, D, E, right? Previous map of S of I. So A should be equal to previous map of S dot length minus 1. Am I missing something here? S dot length minus 1 should give me this last character here. So I should say that A is equal to E. Here, A is equal to S at I minus 1. So if it's 1, then S of 0 is A. Oh, previous map, that's why. So A is still undefined. Previous map of S of I, S of 0 equals S at S dot length minus 1. Let's see what this is. Because again, I feel like this is should be something simple. Okay, it's 4. 0, 1, 2, 3, 4. So you're telling me that S of 4, previous map of S of I. So if I is equal to 0, which it is in the beginning, then we should set, so what's S of I? That's A. So previous map at A is equal to S at 4. 0, 1, 2, 3, 4, which is E. But we're getting undefined. Just for fun, what if I did 2? Still undefined. Man, I'm either doing something like really, really stupid. Okay. Right. So obj at S of 0 is equal to S dot length minus 1. A is equal to E. Is that not what I'm doing here? If I is equal to 0, which only happens the first time, I'm saying that previous map of S of I, the same syntax here, is equal to S at S dot length minus 1. And somehow that's giving me undefined. Extremely confused about that. Very confused about that. I mean, I don't claim to know JavaScript. I'm not like, there's always room to learn, but I feel like I'm doing everything right here. Because we have the B to the A, the C to the B, the D to the C, exactly what I want, E to D, I don't understand why that A is undefined. That's very unfortunate. Because really what I would like to do is the same thing, right? Like my answer would revolve around me doing the same thing here. And for goal, just make sure that the same thing applies. Like I look at the previous one and make sure it's the same value. So like something like, let's see. Let's say let previous, if I equals 0, previous here will equal s of s dot length minus 1, or previous, well here we can say else. Oh, wait a second. That's probably why, right? We should do an else here. Else previous equals s of I minus 1. And here we can say if, let's see, if the previous character is not equal to previous map at s of I, we can return false. Return true. Let's see this. If and else statements. Sometimes it's those basic constructs that get you. So true, true, and true, false. So that's not good. So let's see why that's happening. So let's do console.log previous map. Now let's, okay, use example test cases. Let's just do that second one. I just want to see what previous map is here. Okay, so AE, BA, CB, DC, ED, okay. So let previous, if I equals 0, previous is just equal to s of s dot length minus 1, else previous equals s of I minus 1. So then here, let's see, console.log I and previous, because I want to see the numbers match to the previous ones. I also just realized that I'm not looking at goal. I less than goal.length. Here, this should be goal. Goal, this should be goal. Not equal to previous map at goal of I. Does this change anything? Okay, false and false. Too fast. So let's submit this and see. Ah, okay. Well, that's great. I guess, well, one thing that we could do, because does that, if s.length is not equal to goal.length, return false. Is that the edge case I missed? Let's see. Okay, so let me see. W, it should be R, okay. Before C should be U, correct. Before L should be C. Before R should be L. There's okay. Yeah, I really failed to see like the trick in this one, right? Because that's one thing, like unless they specifically say that letters are duplicated, I need to know that there's a possibility they can't be. I completely went over that. So ask yourself if something good to ask the interviewer, can the letters be duplicated or not? Because I completely went over that and I missed the point of the question. So I think with that being said, I'll probably wrap up the stream today. Yeah, I feel like it wasn't like one of my best streams, but you get some good streams here and there. Like some of our medium streams from recent times have been really great, and then you have like it's weird because I feel like sometimes the medium questions are easier to understand than easy questions. well, it is what it is. I'm going to go ahead and wrap it up here. Thank you all so much for watching the stream today. Hope you all at least gained something from it. If not, at least provided some entertainment value for you all out there. I am hoping to be back online again tomorrow to do some medium questions, but again, it's probably going to be later on in the day since I'm now back in the office full time for a couple days out of the week. And then, of course, I'll be going on vacation. So with that being said, have a great night, everyone. See you all tomorrow.